So this one, we're not actually going to do this question right now, but I want to talk about how you could use the question to your advantage. So this question here, this horrible like algebraic fractions looking question, which we'll practice later. It says, give your answers to 2 decimal places. Now, it also says answers, and it says 2dp. So for it to have more than one answer, it's already hinting that this is going to become a quadratic. So when you times up and you double bracket expand, you're solving a quadratic. But not only is it telling us that, this is telling us something else. This is also telling us not to bother factorizing. Because this will be on a calculator paper. If it says to 2dp, it's also telling you that this quadratic doesn't have nice answers. So don't sit there trying to factorize it because it doesn't factorize. Use your formula, use your calculator function, use whatever other technique, but don't try and factorize it. And these are subtleties in the question that if you can notice them, they save you a lot of time. So please ask me if that wasn't clear, but I'll say it again. Answers, little subtlety, reminding you it turns into a quadratic because there's more than one answer. 2dp doesn't factorize. It's not a nice quadratic. So you need your calculator. Okay, so that's how you can kind of use the question to your answer. To your advantage. What am I saying? The question to your answer doesn't make any sense. The other thing I would say, I think I was looking ahead. That threw me off. This thing here, I get a lot of students asking me, "Oh, sir, what do I do if it doesn't say how to give the answer and it's a horrible decimal?" So if they say to 2dp, you must do it to 2dp. They're testing you know how to round as well. If it says to 3SF, you must do it to 3SF. If they say in exact form, you must do it like in terms of pi or as a third or whatever. However, if they don't say, the best thing you can do is you tell them. So if they don't tell you how to round it, you tell them how you've rounded it. So if the answer is like 3.78524 on your calculator, blah, 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 and they've not said how to write the answer, then you can write 3.79 to 3SF or to 2dp. You tell the examiner, I'm not wrong according to this. I've rounded it this way. You didn't tell me how to round it, so I'm telling you how I've rounded it. And I'm not wrong according to that level of accuracy. So that can be really what's the word I'm looking for? Empowering, because you're in control. If they haven't told you how to round it, you make a sensible decision, you make the executive decision, and you just tell them in a little bracket, I've rounded it this way. Okay? If they ask you specifically to do it to 2dp and you don't, then you're going to lose a mark. But that's what I would suggest for this, that you should tell them if they don't tell you. Oh, sorry, we're going to do, I don't want to, that's a really good question. To those that have actually tried that question, sub it back in and check it if you've done it. Put ANS or your answer button in and check it works out. I don't have the answer right now, but we're going to do algebraic fractions later. Sorry, I didn't even register. People might have been trying that one out. That was just a little bit about exam technique, but we are going to do algebraic fractions. I don't have it to hand right now, but we can maybe check that later. Thank you, though. Thank you for asking about that. But I hope that makes sense about how you give your answer. If it's money, do 2dp, because that makes sense for money. But in general rule of thumb, I would probably do 3SF. That's quite a nice mathematician convention. It's like a standard sort of conventional thing. But like if they don't say, you tell them. And that would be my go-to. Do it to 3 significant figures and say that. Good question. When you do significant figures, 0.00052001, none of these zeros are significant until the number sort of kicks in. So if there's a load of zeros and then a number, the first non-zero digit is the first significant figure, because it's like the magnitude of the number. It's like where the number kicks in. So this 0 is significant because the number has effectively started. But the significant figures, That's actually why significant figures are important. That was a really great question, actually. Because if you were doing like a physics calculation and you were dealing with stuff on an atomic level and everything's like 0.0000, and you just used decimal places, everything would just round to zero. So significant figures are like dealing with the magnitude of the number. So the first significant figure here is the 5. And then that's the second, that's the third, that's the fourth significant figure. So these are not significant. That's why significant figures are better, because they sort of acknowledge the magnitude or the sort of very small nature of the number. Okay, so great question.